And welcome everybody to the Daily Space Weather Show. Just bringing you the most detailed solar imagery and most comprehensive daily space weather you'll find in the known universe. That's the past 48 hours. The videos we started out with are 24-hour videos at 30 frames per second, all from the Solar Dynamics Observatory. So, let's get into some Earth-based stuff. And by the way, if you enjoy the tracks, check out Golden Cat Productions. You can find us all over the internet. The record label started all the way back in the year 2000. Looking at earthquakes and volcanoes. So there may be an imminent eruption at the Reykjanes Peninsula. There was a seismic swarm, and it looks like magma might not be still entering the chamber. Does that mean it's not going to erupt? Well, absolutely not. It could still erupt, but maybe not. Who knows? Ultimately, we don't know. But ground deformation measurements continue. Also Sakurajima, Ibu, Luitolo, Semaru, Merapi, Popocatépetl. Our viewers' favorite volcano to say aloud. Go ahead, folks, say it. Popocatépetl. Also Santiaguido, Fuego, Nevado de Ruiz, Sangay, and Sabancaya all erupting. Next, a convenient 90-day bar graph to show you an earthquake drought. You see that last red bar? Well, that's the last 7 or greater magnitude earthquake. So it's been a while since we had one, which makes us overdue. And statistical analysis is a way to actually guess when an earthquake may happen. But it's little more than that, folks, as we don't fully understand the physics behind the mechanism that causes earthquakes. In other words, it's garbage in, garbage out. You want to forecast a thing? Well, if you have a model for it, it'd be nice to have the variables. If you have the variables, your model will work and have predictive value. That's what science is for. Anyway, these are the 5 and greater magnitude earthquakes over the past 24 hours, starting out with a 5.8 at Fiji at over 530 kilometers depth. That is the largest quake of the past 24 hours, and we're coming at you a little bit earlier tonight because, well, Saturday night, just getting the video completed. Tonight's video premiered at 6 p.m. instead of the normal 7 p.m. time. South Sandwich Islands had a 5.0 as well. And that's it. Only 2 5 and greater magnitude quakes over the past 24 hours. Things have been pretty chill. 10.7 centimeter radio flux is at, 152 solar flux units. 152 for the radio flux. So that's a thing. It's proportional to sunspot number. If you weren't aware, if you're new to the channel and space weather, there it is. The black line represents the radio flux over the past year. The red line represents the sunspot number, and you can see that how proportional those data sets are, perhaps. They're directly proportional, meaning when the sunspot number goes up, the radio flux goes up typically, and vice versa. Directly proportional. When one rises, so does the other. Space Weather Enthusiast dashboard forecasting little geomagnetic unrest for the next few hours. And we did have a CME impact. And we've got 2 different solar wind regimes showing up at the Discover spacecraft. We also saw the solar wind density make it all the way up to 120 protons per cubic centimeter at the ACE, as a dense and very hot plasma filament brushes past at Lagrangian point 1. We'll get to it. First, the last 4 hours of Earth's magnetic moment from space. That is our Geospace Magnetosphere movie depicting magnetohydrodynamic pressure. If you're measuring magnetohydrodynamic pressure, you'll be using the units nanopascal, most likely. Unless maybe it's a stronger field, those fields are pretty weak. Nanopascals, it's a tiny unit of magnetohydrodynamic pressure measurement. Next, we've got magnetic flux density at the ground level, our ground magnetic perturbations map. And shout out to Randy at the Dirty Burger. Randy Bobandy, one of the curators, the original founders of the Dirty Burger. Next, KP index is at 2. KP2 is the average of global geomagnetism. That is a geomagnetically calm condition. And next, we'll look at the real-time solar wind. So here's the ACE. Here's what I'm talking about. Check it out. We saw the solar wind density there make it all the way up above 120 protons per cubic centimeter. So that was at about 3:30 this morning, but it was a very short-lived event there. It was also accompanied by some very hot plasma. If you look at that green line at the bottom, you see some quite vast differences there, orders of magnitude differences happening there in the plasma temperature, and also some big variations in the plasma speed. So hot, fast, and dense plasma brushed past, making it all the way up to nearly 600 kilometers per second. Another little burst of it right there. Since then, things have equaled out at the ACE. So very slow wind now, and only 1.5 protons per cubic centimeter density. Now the Discover is a completely different story. Check it out. We're getting like 27 protons per cubic centimeter right now for the density. So a significant density spike there at Discover. Looks like a CME impact, and I think somebody was forecasting these. Have you seen our previous daily space weather videos? Well, if you haven't, make sure you press the subscribe button and get the world's most comprehensive daily space weather and most detailed solar imagery delivered right into your YouTube subscription feed. Or don't. It's not going to hurt our feelings if you don't. You'll just be missing out on the content. Next are GOES magnetometers, and they're pretty smooth. It's been no space weather storm type sailing. Next are top view ecliptic plane field plot. And has Earth snapped into a South Pole magnetic sector yet? And it looks like it has. Keep in mind this data is over 3 hours old. Let's make sure we just have the latest here. Oh, we've got an update. All right, cool. We should see the Earth in a South Pole magnetic sector. Let's bring up the last image. And it doesn't show. So anyway, it's safe to assume that Earth is now in a South Pole magnetic sector. The last line there doesn't show a potential field surface source line for planet Earth. So South Pole sector, welcome. Welcome to the South Pole sector, folks. Next, our line of sight field plot. And nothing too exciting going on right now. Solar activity has been pretty mild. Here's our line of sight coronal hole plot next. And let's briefly look at coronal holes from the perspective of SDO. So there you go. There's SDO, and let's cut back here. Last image is showing we've got North Pole coronal holes in the south and South Pole coronal holes in the north. So the line is something like this. These are north. These are south. And that's the scenario. So next, moving on to, how about sunspots? What do you think? Sunspots, shall we cover that next? All right. Well, I think we shall. The Royal Observatory of Belgium showing sunspot number here only a little over 100 now, like 102. Sunspot number reaching back down toward 100. So pretty uneventful there, not very exciting for sunspots. Flare probability monitor and scoreboard not showing a super high likelihood of large flares. The likelihood of 3590 now behind the northwestern limb up there in the northwest, way up there. Now getting behind the limb, its likelihood of producing a large flare is now dropping rapidly. So if we don't see one within the next about 12 hours, folks, unlikely to see a large flare from sunspot 3590 until it rises once again in the northeast, and we expect it to. Sunspots that large have a tendency to make it all the way throughout a Carrington rotation, which is one orbit of the sun at the equator. It takes about 25 days. And let's take a look at sunspots. So there's the most active sunspot. That's our T-mass. It has produced a C-class solar flare, but those are the only intensifications we've seen. It's that sunspot right there, whatever it's called. We've rotated the field of view here, yeah, that's the most active sunspot, and it is actually increasing its likelihood of producing a large flare, and we'll show you why here in a moment. There it is, the SDO magnetogram, and I want you to watch this area right here. You're going to see an increase in South Pole magnetism depicted there in black. So you'll see a line of magnetism forming right in this area. There you go. There it is. That is a slight increase in the magnetic shear of that sunspot. That leading umbra there now being trailed by some South Pole-oriented magnetic fields. That's a good sign if you want to see solar flares. A little bit of an increase in the magnetic shear of that sunspot group. So not too bad. And let's move on to some more data here. What do we got next? Proton flux. And there is a significant possibility now of a spike in the proton flux. We could see a solar energetic particle event, as, like I said, there is a higher likelihood of seeing a large flare now from that sunspot in the northwest. There's also some unstable plasma around it. Either of these events could create a proton event. So likelihood of a proton event has gone up with that magnetogram that we just showed you. So largest flare of the past 24 was a C6.25. A C6.25 class solar flare. And let's take a look at our favorite flare wavelengths. This is 131 angstroms. Another 30 FPS 24-hour video from Solar Dynamics Observatory. Not half bad, not half bad. And here's another close-up of our T-mass. The most active sunspot over the past 24 hours has been that group. And that C6.25 flare did occur from that area. Peak flux was at, I think it was 1300 Universal Time today on March 2nd. Anyway, before we get to CMEs, let's talk about some more stats here, like what's going on overhead. There's a star chart for Lehigh Valley, Pennsylvania. We're showing you visible satellite on the meteorology segment today because the sun has not yet set, so we'll have some great imagery for you here coming up in a minute. And let's look at our solar system forecast next. That's where things will be in 1 week on the 9th. We will have a crescent waning moon as we approach the new moon of March early in the month. Next to our astronomy photo of the day, it's the Odysseus mission. And there was a little bit of a mishap there, but it didn't work out too badly. It broke a leg when it landed. However, things did work out. It's upright enough that it is able to do its mission. So there you go. A great example of how things can go wrong and still work out. Next, CMEs. CMEs are pretty important, right? So there is the George Mason University CMEs, and that one out of the east, it is not earthly directed. That one out of the south, also I don't think earthly directed, but we'll get to it here in just a moment with some further analysis. So there we've got Saturn and Mercury there appearing on the LASCO C3. Let's cut to our more zoomed in view. So the CME that we're most interested in is the one that's coming out of the south there. Again, not likely to be earthly directed, but let's just see what's going on with it. It's pretty concentrated, first of all. 1700 we see it. All right, there it is. I don't think it's on the Earth side, but let's take a look at stereo A as well. Take a look at stereo A, folks. So difference imagery on the right, raw coronagraph on the left. And that is Mercury, by the way, and you can actually see what the angular difference is there. So that's pretty interesting. Giving you an idea of the angular difference between the location of stereo A. So you can see the way it's several degrees off of center there for Mercury, whereas when you go back to the SOHO, it's just giving you some idea of the angular difference. Stereo A orbiting a little bit faster than Earth. Anyway, let's get to our custom coronagraphs. And here is the SOHO LASCO C2 and C3. And the SGO 304 angstroms wavelength. So again, that one out of the northeast, that is not earthly directed. That came from behind that new sunspot, from behind the limb. The one out of the south, though, let's see if it has any earthly directed components. Fingers crossed, I don't think it does. I think that was from behind the limb as well. Or it might have been that crown prominence, actually. So these are still 24-hour videos. We'll zoom in one more level here. And yeah, I believe it's this filament that was down here at the crown region, that crown prominence blasted off. So no earthly directed CMEs that I can tell for the past 24 hours. And if you think I'm incorrect, let us know in the comments. We're always interested in viewer comments. So there we'll zoom way in. And here we've just zoomed into the equator here. Those are different wavelengths, by the way. That's 304 plus 94 angstroms. And let's move on to filaments. So, filaments, there they are from Cerro Tololo, and we've got quite a few here. 2 of those are named. And it's this one up here in the northwest, and this one down here in the south. The rest of those filaments could use names, and if you want to name them, do it over on X. Just follow the hashtag #NameThatFilament. Yeah, you can name solar filaments after living people, your friends, your foes, or even yourself at x.com/smashomash. Again, follow the hashtag #NameThatFilament. Here are the past couple of hours from the GOES 16 SUVI, and we still do have a crown prominence intact at the northern polar region. Big old prominence up there, a couple 100,000 kilometers in length at least. Of course, we can't see the far side of it. It could stretch down halfway across the sun, folks. So perhaps that'll be interesting when it rotates in, if it's still there when it does so. Let's get the bonus features, starting with satellite charging hazards. Some minor ones happening here over places like India, Saudi Arabia, Somalia, and the northern Indian Ocean, as low-energy electrons build up on the outside of spacecraft. GOES electron flux here coming up off the floor, finally, for the first time in quite a while. Check out the 7-day. Highest we've seen in possibly months. So there we're back to the 3-day, and check out the 1-year graph, folks. The electron shortage continues. How high have we gotten here? Well, we're still at very low levels. That's how high. So there's NOAA's forecast, and they'll be off by quite a bit with that next green box. The next observation will be quite a bit higher than that. So NOAA, not right on that forecast. Continuing on to the ionosphere. And the F flare is what we're looking at next, which is why we show that diagram. Feel free to pause the video on this frame. It depicts the temperatures of atmospheric layers, the electromagnetic radiation penetration through atmospheric layers, and the chemical concentration of different layers. So here's the F layer of the ionosphere, courtesy of the Australian Government Bureau of Meteorology. So we are going to see a couple little perturbations there, some low-frequency anomalies happening, and if you don't recognize them in the raw ionosonde, well, don't worry, we'll show you the anomalygram. That'll make things more clear for you. There's anomaly in megahertz from a 30-day median. Low-frequency anomaly in red, high-frequency anomaly in blue. So a little bit of space weather coming in, folks, but it's been pretty minor, and that's consistent with the forecasts. Remember, folks, any science, we're looking for things like predictive value. If you want to read about our mission, check it out at smashomash.com/forum/mission. smashomash.com/forum/mission if you want to read about ours. And let's move on to the Global Ionosphere Nowcast. So GPS users may benefit from the left images. Radio users may benefit from the right images. And that's our Global Ionosphere Nowcast. Barb, I just got to put my burgers in your freezer for like 6 weeks, Barb. 6 weeks, 8 weeks taps. Anyway, that's what's going on, and we'll close out with the latest high-res images. And let's check that magnetic shear that we just talked about. Please work. Hey, why click it once when you can click it 3 times? So a little bit of an increase there in the magnetic complexity of that sunspot group, but besides that, things have been pretty calm. Which brings us to meteorology. What is going on? That's better. And we'll start out meteorology with the most radiation exposure that you can possibly get on the surface of the planet, folks. Are you wondering where it is? Well, it depends on what kind of radiation, I guess, but we're talking about ultraviolet radiation, and it's, of course, in the South Pacific. You know, where it's like noontime right now in the summer. Yeah, that's the sunniest place in the world right there. It's the South Pacific. Anyway, here comes our regularly scheduled meteorology segment, starting out with surface winds. Some windy conditions there at Tasmania. Jet streams are next. Not just for the east, but for the central world. We'll also show its surface winds. Surface winds of the west. And the jets. Next, we're showing visible satellite for once. Yeah, the visible satellite. So there are more images of the oblate spheroid-shaped planet known as Earth. Of course, flurfs will claim that this is CGI or something like that because it's stitched together. So, but of course, when you do provide images that aren't stitched together, that's not accepted either because that's, of course, fake. That's the visible satellite. And check out the snow in California. Yowzers, folks. Yowzers, wowzers. So we'll show the 3-day Euro forecast for snow depth. And it's going to continue to snow a bit there, but most of it is already down. So a little bit more to fall in the coming couple of days there, but it's mostly already fallen, it looks like. That is our snow depth map, courtesy of windy.com. Windy.com, they've got a great mobile app you can check out if you like. So here's our weather.gov map. And a bunch of weather warnings there, including some blizzard warnings persisting in places like Nevada and California. If your location is lit on the map, click your location. Weather.gov is the National Weather Service's homepage. And let's move on to some forecasts. First is the pressure and precipitation 72-hour GFS model. So heavy snows there to continue in California, but also some rain mixed in there. So let's move to our total accumulated precipitation forecast. That is total accumulated precipitation in inches. 72-hour GFS model. Next, accumulated positive snow depth change. And, I guess I stand corrected. There's over 3 more feet expected to fall. So, I don't know. Maybe that Euro snow depth map was bunk, but it looks like 3 more feet are going to fall in California there. So, it's a 72-hour GFS accumulated positive snow depth change forecast in inches. It's showing like 30 more inches for that huge swath of eastern California. Last but not least, temperature anomaly forecast in degrees Celsius. Tomorrow, expected to be nearly 70 degrees in Lehigh Valley, Pennsylvania. "72-hour GFS temperature anomaly forecast in degrees Celsius." Yeah. Next, lightning. That's where it's been striking, mainly around the Gulf of Mexico, that is. And Georgia and Florida have had some lightning activity. Jacksonville here currently having some strikes. There we go. There's one in between the center city, Jacksonville, and the airport. Oh, the Naval Outlying Field White House. What? The Naval Outlying Landing Field White House. Okay. If you say so, if you say so. To quote Trevor from Grand Theft Auto 5, if you say so, if you say so. And here's something that I say so. Never try to sneak up on a dragon in its own lair, folks. Sneaking up on a dragon in its own lair is impossible. If the dragon is home, you'll fail. It might let you sneak in, and you might become dragon food. Don't do that. You probably taste badly. It could be harmful for the dragon's health. Next, our U.S. Doppler radar map. There it is. As a bunch of precipitation happening there west of the Rockies and in the western Rockies, also in the northeast, finally clearing out here in Pennsylvania as things dry up for an awesome day tomorrow. Things finally drying up in Pennsylvania. Almost all the rain on its way out here. Next, visible satellite, folks. Visible satellite, yeah. And last but not least, water vapor. So a huge mass of dry air there making its way all the way from Arizona to New York State. Here's your recap. The U.S. Doppler radar showing vertical motion of the air column from ground-based Doppler radar systems. Space-based visible satellite, like what you would see if you hitched a ride on the satellite. And the water vapor map, showing the dry air, the moist air, and everything in between. When your Doppler's unclear, try that. That might help you out. And we hope you enjoyed the content, but it's time to close this thing out. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Going back to the bunker. Whoa!